So when an object is moving to the right, the velocity is greater than 0, so it's a positive number. Okay, when an object is moving to the left, the velocity is a negative number. Okay, remember, the direction is built into the velocity. And when an object is stationary, the velocity equals 0. Okay, so that's not moving. Okay, the object is accelerating when the acceleration and the velocity are both positive or both negative. So this is an acceleration. Okay, that is the product of the acceleration and the time is positive. Now it's decelerating when either a at t or v at t is negative, because what we're looking for here is that the product of a at t, or like the acceleration and velocity, is negative. So keep those in mind as we move forward with the questions. Okay, example 2 asks, an object is moving along a straight line. Its position s at t to the right, so I put this one underneath, so s at t, so it's this graph right here of a fixed point is given by the graph shown. When is the object moving to the right? When is it moving to the left? And when is it at rest? So we know that the object is moving to the right when s at t is increasing. So s at t is increasing between 0 and 2. Okay, it's also increasing after 6. So when t is greater than 6. Okay, we know that it's moving to the left when s at t is decreasing. Okay, so we know s at t is decreasing when t is between 2 and 6. Okay, and we know that it's stationary when s at t is not moving. Okay, in other words, like the velocity is 0. So of course the tangent here, the velocity here is 0, and at the very point where a graph changes from like increasing to decreasing, right here, right at that point, an object is neither increasing or decreasing. So when t equals 2 or 6, because it happens again right here. Okay, example 3. The position of an object on a line is given by this equation here, when t is greater than 0. So of course, usually time is greater than 0. I'm going to say always time is greater than 0, greater than or equal to 0. Okay, where s is in meters and t is in seconds. Determine the velocity and acceleration of the object at t equals 2. So let's do velocity. We know is the velocity at time t is just the first derivative. So it's just 12t minus 3t squared. So now let's sub in 2. So 12 times 2 minus 3 times 2 squared. I get 24 minus, this is 4, is 12. I get 12. Okay, and the acceleration, so the acceleration at time t is just the first derivative of the velocity or the second derivative of s at t. So we're going to start with the first derivative here, 12t. We get 12, and then minus 3t squared, I get negative 6t. Now let's sub in our number 2. So 12 minus 6, 2. So that's 12 minus 12, we get 0. Okay, so at time equals 2, the velocity is 12, and the acceleration is 0. Okay, at what time s is the object at rest? Well, we know that when the velocity equals 0, the object is at rest. So let's take the velocity, which we have as 12t minus 3t squared, and let's equate it to 0. I'm going to factor out a 3t. We're left with 4 minus t. So we know that the velocity, or sorry, the object is at rest at t equals 0 and t equals 4. Okay, so we want to know in which direction. So when we're talking about right or left, okay, we want to know if the velocity, so v at t, is positive or negative. Okay, so in which direction is the object moving at t equals 5? So let's take the velocity. The velocity is, so let's s prime at 5 equals 12, 5 minus 3, 5 squared. So 5 squared is 25 minus 75. This is going to be a negative number. 12 times 5 is 60. We get negative 15. So it is moving to the left because negative 15 is a negative number. Okay, let's continue this on the next page. Okay, so I just copied and pasted the question and then I just wrote the velocity and acceleration. So when is the object moving in a positive direction? Okay, so if we're talking about a positive direction, so we're talking about velocity, we're talking about when does 12t minus 3t squared, when is that greater than 0? Okay, so let's factor out that negative 3t again. Yeah, and we'll just be left with, I'll put this one here, t minus 4. Okay, I'm going to divide both sides by that negative 3, get that out of there. Because the side equals 0, or greater than 0, we can get that 3 out of there. That constant is gone. Okay, so we have to consider when does t minus 4, when is that greater than 0? So this is a little bit more complicated because there's two cases to consider. Okay, since the product of t and t minus 4, like one's a negative. Okay, one's a negative. The product is negative when the first factor is positive, and then the second is negative, and vice versa. Okay, because we could have like a positive negative. Oh, sorry, positive negative or a negative positive, right? So let's consider case 1, and then we'll consider case 2. Okay, case 1 is going to be when t is greater than 0, and then that would mean that t minus 4 is less than 0. Okay, so t is greater than 0, and then let's just bring that over. T is less than 4, therefore t is between 0 and 4. So that works. Okay, now let's just take a look at case 2. Okay, this is when t is less than 0 and t minus 4 is greater than 0. So bring that over. Can t ever be less than 0 while it's greater than 4? No. Okay, so there's no solution there. These two can work at the same time. These two cannot work at the same time. So, therefore, between 0 and 4, the object is moving in a positive direction. Sorry, this is supposed to be positive direction. Okay, if we were to graph this, it would look like this. This is 4, this is 0. Okay, so we know that it's moving in a positive direction. I'll continue with the next slide.